Ethanoic acid is a colorless liquid at room temperature. It has the typical acid properties and forms compounds called ethanoates. A pure sample of ethanoic acid is slowly heated from 0 to 150, and its temperature is measured every minute. The results are represented. So, looks like they started with a solid, and then it started melting here between BC, and then it became liquid, and then at DE is boiling, right? And then EF is gas, all right? And then in one of the questions, it will say, like, how would it continue? So we're going to get into that. Now, how did I know that it started with solid? Because there's no way it will start. I mean, what if it starts with liquid and then boiling, and then this is gas, and then this is what? Nothing, right? Nothing happens after gas. That's why I knew that it started with a solid, all right? Even though it didn't say that in the question. But you guys, of course, are going to read the question carefully. Anyways, the name the change that occurs in DE. So where is DE? DE is right here. It's the change from liquid to gas. So it is boiling. Now, question. If you write evaporation, will it be correct? The answer is no, because DE is when the liquid becomes gas and it happens at boiling point. Evaporation happens at any temperature between melting and boiling. So evaporation happens right here and right here and right here and right here and right here. All of this is evaporation, right? Because it's happening at any time while it's a liquid. But once it touches the boiling point, it's not evaporation anymore. It's only boiling. So that's a common mistake as students write evaporation, and I take out a point and they get upset. But here you go. It's only boiling, guys. Don't get upset when I take out a mark, right? Okay. What would be the difference in the region BC, which is basically the melting, if an impure substance had been used? So what happens to, again, BC is melting. I know that because it's the first line. And it's asking what happens to the melting if it was impure. So it's going to be, the region BC is going to be at a lower values. Why? Because melting points decrease if you have an impure substance, and boiling points increase. But they're not asking about boiling. They're asking about melting. The other thing happens is that it would be over a range. And would be a range. Now, it's only one mark, so you can either write either of them and you still get a point, or you can have both. You have a whole line, so you do have the space to write everything. Okay. Sketch the graph of how the line would continue. How would it continue if it was heated at a higher temperature? It would just go up and up and up and up and up forever. It's a gas, so the temperature of the gas is just going to go up forever. Okay, you're just gonna draw a straight line with your ruler. Okay, not with your hand. All right, and it's just gonna go forever. And I've seen students ask about this, like, does it get horizontal again? Oh, no. Is there anything else after gas? No. It just becomes a gas forever. Okay. All right. Complete the table. Here are 5 marks that are a gift from the examiner. All right, so it's asking about CD and EF. So what is CD? I'm gonna go back to the diagram, and CD is liquid and EF is a gas. Okay, so I'm gonna write that down. CD is a liquid and then EF is a gas. So basically here you're describing the separation in a liquid and a separation in a gas. So separation in a liquid, they are close to each other, but they're not tightly packed. Okay, they're close to each other, and in gas they are very far apart. Movement in liquid, they are random and slow. Now they're giving you a hint over here. They want you to write something about the randomness and how fast it is. So in gas, it's also random. The movement is random. The movement is not like it's not like a gas particle will say, oh, okay, I'm gonna go right here first, and then go right here second, and then I'm gonna go to this place third, and then I'm gonna. No, it doesn't think. It's random. Okay, it just goes everywhere and anywhere, and it's like all over the place. No thinking. Okay, and then liquids are slow, but gases are fast. So random and fast. Can particles move apart to fill any volume? So in liquids, they cannot fill the whole container, So if you have, for example, a bottle of water and you have a little bit of water here, does it fill the whole water and look like this? All right, no, it just stays, at the bottom, taking a very specific volume. In gas, it's going to fill the whole container. So gas will fill the container or fill the whole volume or take the whole volume.